Approximately 4.5 billion years ago, the Earth formed from particles left over from the creation of our Sun. Gravity drew these particles together to form pebbles, which then formed boulders and eventually the Earth. At its heart is a solid inner core covered by a liquid outer core. Above this sits the mantle made of flowing silicate rocks and a rocky crust. This rocky mass is the third planet from the Sun, orbiting the star from an average distance of about 93 million miles. It's close enough to the Sun to be warm, unlike the cold gas giants, but not so close that its surface is exposed to extreme heat and solar radiation, as is the case with Mercury. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe.
From our perspective, Earth's mountains and trenches are mighty indeed, but when you look at the Earth in cross-section, you can see how tiny they actually are. The part we stand on is the crust, which is about 50 kilometers thick, though it can vary between 5 and 70 kilometers. By the way, the deepest hole ever drilled by man is 12.262 kilometers deep. After the crust comes the mantle. It's a silicate rocky shell and about 2,900 kilometers thick. The mantle consists of the upper mantle and the lower mantle. The upper mantle has different regions too. Its upper part, which is viscous and carries the crust, is called the lithosphere. After that, there comes the asthenosphere, which consists of less mobile, mostly solid material. The lower mantle reaches deep down to the outer core of Earth. Earth's outer core is a liquid layer of iron and nickel, about 2,266 kilometers thick. Temperatures vary from 4,000 degrees Celsius to 5,700 degrees Celsius. And in the center is the inner core. It's mostly solid, a ball made of an iron-nickel alloy, with a radius of about 1,200 kilometers, 70% the size of the Moon, and about the temperature of the surface of the Sun. It is slowly growing at an estimated rate of about 1 millimeter per year. Now for some perspective. This small layer of crystallized melt products of former molten mantle is where we live.
Earth's surface, a layer of liquid metals churn and flow. This generates electric currents that then produce magnetic fields that all together encompass the entire planet. Called a geodynamo, this process causes Earth's poles to attain positive and negative charges, turning the planet into a giant electromagnet. This phenomenon also creates a protective layer around the planet. It shields us from the most harmful radiation in space, leaving us to enjoy a world held together by the strange and fundamental force of electromagnetism.
There's Earth's magnetic field. It's an invisible phenomenon that diverts high-energy particles coming from the Sun and other sources, allowing for a stable environment with comparatively little radiation impact on Earth. But why is it there? Actually, we don't really know a terrible lot about that. We know it has something to do with the core of the Earth. Inside this metal sphere, large electrical currents flow in complicated patterns. They cause a magnetic field that sort of stabilizes itself according to the laws of electrodynamics. This entire system is called the dynamo. But don't let us fool you into thinking we have it all figured out. What about the airy stuff that surrounds us? By volume, dry air consists mostly of nitrogen, oxygen, argon, carbon, a variable amount of water vapor, and small amounts of other gases. Humans are very dependent on the lowest layer of the atmosphere, the troposphere, where the weather is. It's 12 kilometers thick on average. Above that is the stratosphere, which is where the ozone layer protects us from the Sun's most aggressive type of light. Above that is the mesosphere, the coolest place on Earth, with an average temperature around minus 85 degrees Celsius. At about 80 kilometers up, the thermosphere starts. The transition to space is a fluent one without clear borders, but humans decided that space starts here. At about 100 kilometers, Earth stops and space begins, though the atmosphere extends a bit further. In this region we find the ionosphere, the aurora borealis, and the ISS. And the outermost layer is the exosphere, stretching up to 10,000 kilometers. It merges fluently with outer space where there's no atmosphere at all. The atoms and molecules in this area are so far apart that they can travel hundreds of kilometers without colliding with each other.
Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine.
Okay, humans in their present form have only been around for 200,000 years. That's 0.004% of Earth's history. Not long, really. And here we are now, living in a thin, moist layer on a small, wet rock. We call this rock Earth. It is the product of the universe's deepest workings, the result of a constant process of creation and destruction, happening all over the universe all the time, helped by chance, the laws of the universe, and random events. We are really lucky.